Well, hello everybody. Mr. Morales here. And my dog did not like that I just did that, by the way. Okay, hey, Mr. Morales here. And we are going to talk about diagonals and reflective symmetries. And we're going to do that using some regular polygons, which means we've got to learn a couple of words. First of all, what the heck is a polygon? Well, you guys know me with definitions on here. I'm not going to write these out. It just looks too ugly. But I'll tell you, and you can write it in your own words. A polygon is a closed shape. In other words, all of the sides are going to meet at touching corners, not like this, okay? A closed shape with 3 or more straight sides, okay? It's a closed shape with 3 or more straight sides. All right, so that's what a polygon is. What is a diagonal on a polygon? Well, a diagonal on a polygon is a line that goes from one vertex, so a vertex is a fancy word for corner, to another non-adjacent vertex. So, in other words, it's a line that goes from one corner to another corner that's not right next to that first corner, because that's called a side if you're going to an adjacent corner. So, I'll show you some examples in a minute. Okay, what is a line of symmetry on a polygon? Well, here's kind of something that I said. When a shape reflected over a line of symmetry when a shape is reflected over a line of symmetry and the shape is reflected onto itself. Wait, I wrote that. I don't know. I'm looking at my answer key and I hate the way that I said that. So I'm going to change that. When a shape Okay, so here's what a line of symmetry is. It's a line that, when a shape is reflected over that line and falls on itself, that's called a line of symmetry. It's kind of the idea if you have a shape and you fold it in half, the crease mark is where your line of symmetry is. Sorry I said that horribly. I need to go back and reword that in my answer key before I print that off. But hopefully you have the right idea, and if not, we'll talk about some. Okay, so, yeah, we need to learn the names of some specific polygons because that's going to show up on our test. If we have a regular polygon, or any polygon that has 3 sides is called a triangle. You guys knew that. Okay? Now, some of you, for the 4-sided, are tempted to write square or rectangle or something like that, but there are tons of different kinds of 4-sided polygons. So, the general name for all of them is called a quadrilateral. And then a 5-sided thing is a pentagon. And then we have a hexagon. A 7-sided one, this is tricky for people, is called a heptagon. So it's kind of like hexagon, but heptagon. 8-sided is an octagon. 9-sided, this is kind of silly, is a nonagon. And a 10-sided is called a decagon. Okay? So what I want to do for you guys here is I want to go ahead and take you through the process of finding different lines of symmetry and diagonals and things like that. So let's start here with a triangle. So first of all, we need to draw the diagonals and say how many there were. Draw lines of reflection and say how many there were. Okay? So, yeah, let's do this. A diagonal. Well, our definition of diagonal was it was a line that goes from one vertex to another sorry, I just paused for some reason. It goes from a vertex to a non-adjacent vertex. Well, this vertex over here is adjacent because it's right next to it. And this one over here is adjacent because it's right next to it. Same thing could be said if we start here, well, these two are adjacent. If I start here, these two are adjacent. So it turns out, sorry, I don't know what my problem is. It turns out that a triangle doesn't have any diagonals because there aren't any non-adjacent vertices. But it does have some lines of reflections. Okay, so we're assuming this triangle is a regular triangle, so all of the sides are equal. Well, we want to find lines of reflection that would reflect the shape onto itself. Well, it seems like if I kind of imagine a dot here in the middle, we talked last semester, or last unit, about how we need this dot to go across the line of reflection at a 90-degree angle and the same distance. Like, we want these to be the same distance. So if I kind of make a 90-degree angle here, and then I would want to go up to the vertex like that, it seems like if I fold that triangle on that line, that I'm going to get a line of reflection. Same idea here. I can just go straight there, making sure I've got a 90-degree angle. And I could go like this and make sure I've got a 90-degree angle here. So it looks to me like we have 3 lines of reflection. Alright, let's go ahead and look at this hexagon down here in question 8. So why don't we start with the diagonals? So if I'm going to start here with this vertex, I need to draw lines that go to the other non-adjacent vertices. So this vertex here is adjacent because there's already a line here, so we just ignore that. And same with this one down here. But I could draw a line that goes to this corner vertex, and this vertex, and this vertex. Well, that's 3 of the diagonals of this shape. But I could also draw one like this, and like this, and like this. And I can also draw one like, oh, okay, so notice I've already got one going here, so I don't need to redraw that line. But I've got one here, one here. Oh man, I need to be keeping count. Okay, I'm going to erase these and I'm going to start over and keep count. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like there were 9 diagonals on that hexagon. And if you draw that with a ruler, it actually looks really cool. Okay, lines of reflection. I need to know where I can fold this shape and end up with it going onto itself. Well, it kind of seems like if I draw a line here, if I folded this shape right there, that like this dot would go onto that dot, and this side would go onto that side, and this side would go onto that side, and this side would go onto that side. So that seems like a good place to go. And my hunch is that I could do that across for any of these corners, like that. But I'm also getting the impression that I could do this in this example. I could fold it right down the middle like that. And for that same reasoning, I can go down the middle that way. So counting these up, it looks like I have 3 red lines and 3 yellow lines. So in this example, there are 6 lines of reflection. Oh, don't forget that level 2 goes on to the other side. So let's head there now. Okay. Why don't we do question 9 together? Okay. Okay, diagonals. Help me keep count. Hopefully I don't mess this up. I'm going to just start at one corner and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Yep, there were 14 diagonals on that shape. And again, look how cool that looks. And it looks even better when you use a ruler. Okay, lines of reflection. Now, in the hexagon example, we went from one corner to the other. So, like, if I went from one corner to the other, that doesn't look very symmetrical. Because, like, for example, here, I've got 1, 2 corners on this side, but 3 corners on this side. So it doesn't seem like if I fold this shape on that line that I would get the same shape. But why don't we try this? What if I went straight down from a corner to the other side? Well, that looks pretty good. Because, like, I know that this side would fold onto that side. This dot goes onto that dot. This side looks like it would go right there. This side right there. And this little half goes with that little half. Yeah. And it almost seems like we could start at any corner and go across to the opposite side. So this corner to the opposite side, this corner to the opposite side, this corner to the opposite side, and this corner to the opposite side, and finally this corner to the opposite side. So I was counting in my head, that was seven lines of reflection there. So I wonder what the difference is between this shape here, might be worth thinking about, and the hexagon in this example. How come we could go, like over here we went from corner to corner and side to side in this example, but over here we had to go from corner to side and corner to side. Huh. It's worth thinking about that kind of a question. Okay, oh my gosh, well, how much, okay. Well, my best advice here on number 11 for the diagonals is to just do it carefully. In fact, maybe what I've seen some people do in the past is go 1, 2, 3, 4, 5, 6, and they write the little number 6 to show that they drew 6 lines from right there. And then they would go 1, 2, 3, 4, 5, 6, and write a 6 there. And then notice here, once I start on this corner, I've already got one connection there. So this is just 1, 2, 3, 4, 5. And then this one already has 2 coming off of it, so it's 1, 2, 3, 4. Huh. Okay, so I'm going to let you finish that up, but that's my advice for these big shapes, is to kind of write down those numbers next to them. Might help you see a pattern of some kind, and stuff like that. Okay, well, I'm going to wish you guys luck on your endeavors, on your homework. I'm so excited to receive your homework tomorrow and look at all these cool patterns. If you go check out my answer keys, I have like perfect diagonals drawn in, and you can see how cool these shapes are. I freaking love diagonal art. It's like my favorite. Okay, I will see you guys on the flip side, bro. Bye.